Derived state is one of the most powerful concepts in all of programming, but I think it's one that's not appreciated as much as it should be. For example, let's take a look at the state. So here we have a simple variable, as simple as it can get, name equals Mike. We can easily update the name by just setting name equal to something else. Now, what was if we didn't want to change name, but wanted to adapt it to be something else? That's where derived state comes in. So here we have name and age, but then we have a message which is derived from the name and age. Simple enough, right? But what was if we wanted name and age to be changeable themselves, but still reflect that relationship that message is? Well, that's where functions come in. So this getMessage function is takes name and an age and returns that relationship. The message name is age. We actually do this kind of thing in the React world all the time. So here's a standard React functional component. It takes a name and age, and it returns back some derived state, some React elements. Using React's useState, we can contain that state locally within the component itself, so that when we click a button, for example, we can change the state, but then the derived state, which is the React element, is always going to stay up to date because of the magic of how useState works. Now, the problems start when we want to do more than just have our local users see our lovely state. We want to be able to share that with many clients. So this generally means moving our state to the server for distribution to various clients. So here we have our React component again, except this time we're now loading the state from the server when this component mounts. So we're fetching, and then we are returning some JSON, and we're setting the name and age local state from what is returned. If it's undefined, it means it's loading. And then we are just having the derived state updating. Now, the obvious issue here is that when we click the button to set the age, this is only going to set the age locally. It's not going to set the age for all other people who we want to see this website or app. We can fix this though if we change the button so that it's now, when it's clicked, sending a message to the server to update the state, and then we reload the entire page, which then causes it to be the state to be fetched again, updated, and then we get our derived state again. Just looking at this a bit more closer though, I think we can probably simplify this a little bit more if we combine these two together and then we simplify this use effect. We'll have to change this loading here to be message. Then we can go down here and we can now update this. So what's happening now is that our message, our derived state message, is being given to us from the server directly, and we're not calculating that derived state locally. Great, so now our derived state comes from the server on request, but what happens when another client updates that state? So what's going to happen is we're going to have one client that is seeing that the age is 21, and we're going to have another client that is seeing that the age is 20. This is obviously not ideal, because ideally both clients at the same time are going to be able to see the same state. And the reason why this happens is because we have no way of the server notifying the other clients when that state has changed. Now, I could start talking here about WebSockets or server-sent events or server-side rendering or anything like that, but let me just cut to the chase and just show you how Convex solves this problem in a really, really elegant and neat and powerful way. So first and foremost, Convex is a database. It's a very powerful reactive database, but it's a database. And as such, we define a schema for our database. This is the structure that our state is going to have, and it's going to be stored, persisted on the server. So we can see we define a schema, we define a table, and we define our 2 bits of state here, name and age. Clients then access that data by using queries on the server. So here is a standard Convex query called getMessage, and we can see the first line here is where we actually pull the data from our database. We're pulling down the first row of my state. If it's not there, we're going to throw an error. It should be there. For the purpose of this demo, we're going to assume that it is there. And then we do the magic part. We do our derived state. And similarly, to update the state, we have to write a mutation. So here we have our reverse aging mutation. And as before, we grab the state from the database, the first row, assuming that it's going to be there. And then we patch it with whatever the current value of the age is and then subtract 1 from it. Okay, so now from the client side, we can update our React component to use Convex. So the first thing we need to do is pull in our React client here, pull in the dependency for that. Then we can pull in our API, which is automatically generated for us when we run Convex dev. Then we need to replace where we pull our state from the server. So we just delete that, stick this in here. So now we can see that when we're mounting, we're calling convex.query to pull down our get message, and then we're setting the message up here. And just a note here that this API is entirely type safe, and so if I misspell something, TypeScript is going to yell at me, which is very handy. And so the final thing we need to do here is just scroll down here and replace this bit, which is what happens when we click the button. So we're now calling our convex mutation, and then once that returns, we then reload the page like we were doing before. And this would work. I mean, we're replacing one for one what we had before, but this is Convex. We can do one better than that. So what we can do next is pull in our special hooks here, use mutation and use query. And then all we need to do is replace all of this code with this. And what this is going to do is effectively is us just stating that we're interested in that piece of derived state, the state that is derived from the age and name. And it's up to Convex to worry about what happens when either of those values change and keep us updated with that latest state. And then same for the mutation side, we can simplify things. If we pull in our use mutation, we then have our reverse aging function here, and we can just stick that in here. And note, we no longer need to reload the page because our use query is going to automatically keep us up to date. So once we change the state, we don't need to reload the page. We don't get any jank. It's just immediately the state is updated for us. And just to illustrate that derived state via queries applies to just about everything in Convex, let's take a look at a little bit more complicated example. So if I just paste in here, so we now have a table that represents a list of messages in a chat application, for example. It has a channel, it has a body, and it has from the user that it came from, and we have an index on there. And then from the query side, we can just replace this with this function, this query get messages in channel. It takes the channel that we're interested in, and then it queries the messages table that we just defined with that index that we defined, and we're passing in the channel that we're interested in. And what this is going to do is it's going to only going to return back the messages that are related to that channel. And don't forget, this is just derived state, it's reactive derived state. So take, for example, if we have a look at this diagram here, we have our list of messages in our table belonging to different channels, general, random, stand-up, general, whatever. This query is only going to return us ones that belong to, let's say, the general channel. So that if we have another message that suddenly pops into the bottom, message 6 here, if we are only subscribed to random, for example, then that message is not going to update that query. It's only messages that are related to the queries that the client is interested in. So yeah, this is really powerful. It means that the reactivity is fine-grained enough that it responds to the very specific filtered query that we are interested in, the very specific derived state we're interested in. And we can combine that state from multiple tables if we wish. So what ends up happening is, because it's so easy to write these queries, we can basically just write queries that are very specifically needed for our front end. So for example, like here, a query, get the state needed to render my sidebar on the settings page, for example. And then on our client side, we just use our use query and then we point it to that. And it just makes it effectively like your server is your derived state, and it's reactive, so you know that it's always going to keep all your clients updated. Yeah, and this concept is, I think, is called Backend for Frontend. And it's a really powerful and very quick way to develop your apps and know that all the state is going to be kept in sync with everything, and all users are going to get a really nice experience doing this. So I hope through this I've shown that I consider convex queries to be the ultimate form of derived state. It's super powerful, and I'm only just barely scratching the surface of what you can do here. There's much more I could talk about, but I will save those for future videos. Thanks for watching.